So in this case, we've got transformation sine pi z over a. So we want to look at the real and imaginary parts of this. So we just use our formula sheet to rewrite, well, the real part of this is sine pi x over a cosh pi y over a, and the imaginary part is cos pi x over a sine pi y over a. So what we're after, again, is a region which will map to the upper half plane of the W plane, the upper half of the W plane. So we just want to find one region which does that. So for that to happen, we want x to have all possible values. X and y obviously are real numbers, we have to bear that in mind. If y is real, then this is always positive. So to get all possible values of this, all possible values of the real part, we need this to be of either sign. So one way of ensuring that this is of either sign is to make x vary between, well, to make this argument vary between pi by 2 and minus pi by 2. So we can do that by choosing x to be a over 2, vary between minus a over 2 and plus a over 2. And once we've done that, we then look at what happens here. So if we choose that, thinking about what cos does, in this region this is positive. For these range of x's, this is positive because that gives you, this argument is between minus pi by 2 and plus pi by 2. So this is definitely positive. So, and we want just positive. So that means that we need that y has to be greater than 0. And that's enough to define the region in the z-plane. So we end up with, if I draw this, we've got so this region here will end up getting, in the z-plane, will end up getting mapped to this region here. We can also, it's also interesting to consider what happens to this region here. This region here, this is strictly positive, which means that this region inside the red shaded parts, or bounded by the red shaded part, will get mapped to, obviously this is still imaginary part greater than 0, but the real part is also greater than 0. So this will get mapped to this region here. So if you want just a